That is not good.
I'm Rod, and this is Rod Rides and Wrenches, and today I'm finally going to start tearing into my KLR650. If you remember a few weeks back, I did purchase this bike up on Vancouver Island, and I said it needed a little bit of work, and that's in fact the case. It seems to run okay, but it's been neglected for a number of years, so we need to figure out what works, what doesn't, what needs to be replaced. And so far I've amassed a small pile of maintenance replacement parts that we're going to be putting on the bike as well. We know the front forks leaks, we know it needs chains and sprockets. We need to investigate the timing chain tensioner, which is a known issue on these bikes, as well as a few other things. So we're going to start tearing this apart today and see what's here. I also just want to point out one quick thing, which is I've never owned a KLR650 in the past. I've played with the idea, thought about it a lot of times, but never managed to get one. So if you have a KLR650 or have some experience with the bikes and want to share some information, please be sure to put it down in the comment section. I would very much appreciate that. So what is a Kawasaki KLR650 and why the heck should you care? Well, the bike is a single-cylinder 652cc triple sport. That's right, you heard me, triple sport. That allows a rider to enjoy a bit of off-road while being able to ride on highway and even do some light touring. It's not a Hall of Fame bike for either on or off-road on its own, but if you're looking for a bike that can do both handily, the KLR650 is known as one of, if not the best bikes you can own. Based off an early production bike at the height of the hairband era, the 1984 to 1986 KLR 600 was definitely more dirt than street, with a kickstart only engine, over 34-inch seat height, and a motocross-inspired air assist suspension. The early liquid-cooled 564cc engine has stood up over the test of time, however, while many of its competitive bikes, like the Suzuki DR600 and Honda XL600, with their air-cooled thumper design engines, have become harder to maintain as these bikes are now closing in on 40 plus years old. What the KLR 600 did was show Kawasaki engineers how to produce a reliable and usable bike that the public wanted, and they were able to do it at a lower price than either Honda or Suzuki. Enter the KLR 650 in 1987, a bike built so well it received very little in the way of updates and changes until 2008. The double overhead cam engine now touted 652 cc's of displacement and a rear disc brake to replace the former drum used on the 600. The KLR 650A and the following B model, which was introduced in 1990, were the same bike, with the KLR 650B or Tangai receiving updated fairings and is distinguished by the front fender mounted to the lower fork tubes. This was done to protect the bike and rider and give a more on-road appearance while emulating the top-to-car motorcycles of the era like the Africa Twin and Yamaha Tenere. The low fender was removed on later models though, as it proved less than ideal in mud and running over trails. Last month the channel hurdled a minor milestone, and I just wanted to take the time to thank you, our loyal viewers and subscribers. So here's to you. My first task for the front end was to tackle the leaking forks.
So it's another lucky me situation, repairing these forks, and the bolt that is holding the damper inside is not coming out. In other words, I've got it loose. I use some MAP gas to get the bolt loose, but what's happening is the damper inside is actually spinning. So I get this question a lot from my other videos, and that is, how do you remove this? And you do it with this guy right here, which is my long piece of aluminum. What we're going to do is stick this long piece of aluminum into the fork, up against the damper, turn it upside down, and push down while we loosen the bolt. Now you can actually see the damper spinning when I don't put any pressure on it. You see it spin the rag. So you have to use some pressure. You have to push down and try to hold that. So now what I've done is I've just put the fork tube down here and put that aluminum rod that I have pressed up against the damper in a vise. So this will hopefully allow me to hold this down a little bit better. There, finally, just a little bit of persuasion, and we got it out.
With the forks apart, they were cleaned and checked over. Now the forks were in need of a complete rebuild. Luckily, both the upper and lower guide bushings were included in the all balls rebuild kit. Usually when you remove the inner or lower bushing, you can just use a screwdriver to spread the bushing far enough apart to get them off the upper fork tube. The bushings on our KLR650, however, did not look like they actually fit the 41mm fork tubes, and they have about a ½ centimeter gap where the bushing ends joined on the tube. I wondered if these forks were previously rebuilt with the wrong bushing. Maybe these bushings were from a first-gen KLR that used a 38mm fork. The screwdriver method didn't work, so I used a pair of snap ring pliers to spread the bushing. When installing any components on your forks, be sure to lubricate them thoroughly with fork oil. The new bushings went on easily and had a more typical 1 to 2mm gap in the opening of the bushings once installed. Installing the upper, or sometimes it's referred to as the outer guide bushings, it can be a real hassle. It's important to hammer them in while using something other than your new fork seals. I used a couple of old steering stem races against the bushing washer, and if the bushings get difficult to reach with the driver, you can use the old seals taken off the fork to help drive the bushings home, since these old seals are going in the trash anyways. Again, it's important not to hammer the new seals any more than needed to get them seated into the fork properly. While talking about fork seals, it's also important to make sure they are installed in the correct direction, and it's not always obvious. The fork seals have 3 inner oil wiping rings, 2 rings close together referred to here as the sealing lips, while the third sits a few millimeters apart. The 2 seals that are close together need to be positioned down toward the lower fork slide tube in these conventional forks, or if your fork is inverted, they would be positioned facing up. Just remember that these 2 closely spaced fork sealing lips are positioned toward the oil in your fork and your fork slide tube, whether conventional or inverted. With our forks ready for oil, I set the air gap, which on the KLR is 135mm with the fork tube collapsed, using Repsol 10 weight fork oil. Adding too much oil to your forks can make the action in them harsh and damage your fork seals, while too little fork oil can damage your internal components and bushings. Using a fork leveling tool like this makes setting the right level so much easier. If you want more rebuild and maintenance tips for suspension, brake, steering, or final drive, be sure to check out the links below in this video's description to my more detailed videos. With the forks out of the bike, it's easy to check the steering stem bearings. The KLR650 comes from the factory with caged tapered bearings on the steering yoke, so repacking these bearings with lithium grease is straightforward. Steering stem bearings repacked and yokes reinstalled, the assembled forks can go back in the bike, and all that was left now was to align the forks to their proper position. The rarest of the early KLR 650s, though, is the C, which was sold in world markets and not in the USA and Canada. The KLR 650C is distinguished by a dual-piston front brake caliper, which later became standard on the second-generation KLR, stiffer suspension springs, a gauge cluster that does not have a tachometer or coolant temperature gauge, and a smaller 14-liter fuel tank. The rear on the KLR 650C is more form-fitted to the bike and is often regarded as sleeker-looking. This bike was made for more diverse climates and countries where roads were rougher and only the necessities mattered. The C model was also rumored to have a carburetor anti-icing system as part of a heat-controlled idle. In 2001, production of the KLR 650 was moved from Japan to Thailand, and this is the factory that produces the second and now third generation bikes. In 2008, the KLR 650 second generation bike was introduced. This KLR received updated plastics, although most riders find them brittle and they unfortunately brake easier. The aforementioned dual piston brake calipers, both front and rear, slightly lower suspension to reduce the seat height, and a little more weight. One of the most significant significant differences, though, I think that most KLR owners would agree, was that the second generation bike received an updated electrical system with an alternator stator, while the first generation bike had a direct current generator. This means that if your battery goes dead in a second generation or third gen KLR 650, you can't bump start it, while the first generation KLR can be started with a stone dead battery in place. Despite losing the DC generator, though, the second generation still picked up about 15 pounds of weight, but many feel the second generation bike is an easier bike to live with day to day, which is what we have here.
I never really know what's going on.
The other really rough area of the bike was the brakes. They didn't really work at all, which was another reason the bike couldn't be ridden home in the first place. The caliper seals were corroded in place, and the pistons were some of the most difficult I've ever removed. To help with cleaning the pistons and calipers, I bought an ultrasonic cleaner, specifically for brake calipers, small parts, and carburetors like the one on the KLR here. The calipers and pistons took a couple of hours in the cleaning tank with a special solution, but came out prepped, ready to rebuild. The real payoff with the ultrasonic cleaner, though, is while it was working, I'm free to do other things, and just pull out my clean brake parts when the timer runs down to 0, give them a quick rinse, and we're ready to rebuild. Now it was time to tackle the rear of the bike, and one of the things that you should watch out for on a KLR is the swingarm pivot bolt and bearings. These bearings are not packed with grease well from the factory, and the pivot bolt has no anti-seize compound. So if you own a KLR 650 and you haven't pulled and lubed these bearings, you'll be in for as much fun as I'm having here. The real problem for me, though, was the bolt that holds the rear suspension rocker arm to the frame. There are 2 roller bearings in the rocker arm where it mounts to the frame. Now, these bearings need to be lubricated with grease every 2 years along with the rest of the suspension and swingarm bearings. I would guess this rod bolt has never been out and obviously never greased. To get the bolt to start moving, I heated the frame with MAP gas. Lighting a small fire to the carburetor overflow hose, I forgot to move out of the way. Fire out, and using a drift punch with a very large hammer on the side, eventually the bolt started to move. Here is what the bolt looked like after coming out of the bike.
Okay, so it's still warm from the heat, but you can see why this guy was stuck in there. I mean, just look at that corrosion.
Corroded without any anti-seize or lubricant. With all the pivot and swingarm bearings lubed with moly grease on the KLR, everything went back together smoothly. Remember that rocker arm pivot bolt? Well, I cleaned it up and coated it with copper anti-seize before reinstalling and torquing it to 98 Newton meters. The swingarm pivot bolt is torqued to 88 Newton meters. The tie rods and lower shock bolts are also torqued to 98 Newton meters.
We are lubed and torqued.
My freshly lubed rear end is ready for the tire to be reinstalled. And with that, we are also installing a new chain and sprockets. Now, I thought about adding a couple of teeth to the rear when ordering these, but stuck to the stock 43-15 tooth ratio. KLR owners, I would like to hear about your experience using different sprocket ratios, so put it in the comments section below. Next up, we're moving into the engine, and we've got to make sure that we have the balance chain tensioner set properly in this bike. This is one of the critical failure points in a KLR 650 for the first and second generation, in my understanding even the third generation, and sometimes is referred to as the Doohickey. It's kind of a stupid name, but what we're actually talking about here is the balance shaft, and it keeps the vibrations to a minimum and the chain that runs from the crankshaft to this balance shaft. We're going to take the valve cover off and inspect the valve clearances on this bike, and I have a new spark plug for it, which we'll throw in for good measure. Once we're finished with the engine, I have some special items that I've ordered for the bike that are going to just bring the trim level up a little bit, offer the bike a little more protection, and should make it a little more distinctive, a little more me.
So the most it gets up to is 75 psi. Now we can lift the cam out. One camshaft, second camshaft.